Yeah, yeah. Let's get started. So I'm recording the session. Go. Okay, so let's take a look at Brightspace. Um, so this is week 2 lab. We've completed 1 lab already, which is already assigned. Went over the problems. So yeah. So let's take a look at Brightspace here. Contents. And it's basically this one, secret key encryption. So we used OpenSSL essentially to explore some of the ideas of cryptography. So far, you've managed to encrypt a few things. And then we'll just continue building on this idea. One big component of this course is the algorithms themselves and just understanding how they work. So you have a notion already of XOR, etc. So today I'm going to go over this example, Python. It's an introduction kind of to Python. We're going to implement, it's just one problem. We're going to implement a very simple substitution cipher, right? This is the only traditional cryptographic algorithm that we'll cover in this class, which is the substitution cipher. And it's, there's like 2 goals with this example. The first one is actually a lot of the functions, the way that we're going to use it is going to be pretty consistent throughout all semester. So we're going to have encoding functions, decoding functions. So some of the code we'll use again, we'll use throughout the semester. Obviously, the complexity is going to change. Instead of using a substitution cipher, we'll start adding things to it. XOR operations, modes of operation, and so on. Okay, but yeah, we'll start with this one. So that's one of the goals, just to get started with Python and implementing an algorithm. The second one is to show that, this is an insecure algorithm, like completely insecure. This is not something you should use for cryptography, yet it's still complicated, right? So if you have to solve it on your own, it may be a bit of a challenge, right? So that's kind of the idea there, is that we look at this algorithm, it seems like it's quite involved and complex, but it turns out is very insecure. And so there's a pattern in the structure of it. And so it's something that you could break. But so yeah, so those are the 2 goals. And then later on, as we start moving on, we'll take this same script and start changing it to implement Python XOR and so on as we move on. So this will be one script that we'll probably cover today in class. So let's take a look at what the assignment will be. Okay, so remember, these are just copied over from last year. So let's read through it. If there's anything. So complete the substitution cipher problem as covered in class. So I'll go over this and very slowly help you out to understand. We'll think through the basic ideas. And there's really like some basic mechanics, and then there's like one complicated part that may or may not be difficult to you. All right, so let's take a look. The Word document I'll certainly keep. And it says here, yeah. So this is a substitution cipher. So complete the following problems as done in class. Submit a report showing evidence that you completed the Python substitution cipher as discussed in class. You need to run it without errors and show evidence of encrypting and decrypting something. Don't just give me code. Okay, so I'm giving you the code. It's on Brightspace, right? Or on the GitHub. So if you just give me code, I mean, 0, right? I mean, you're just really giving me what I gave you. You have to run this code. You have to encrypt, decrypt, show screenshots in your report that you got it to work. Does that make sense? Any questions about that? All right, so yeah, that's it. So I'll go over this today. Should be a nice practice. Ask questions, follow along. But it's your first encryption algorithm, and it's a, pretty simple classical algorithm. All right, so let me add the since we'll probably finish this today, we'll have more than enough time, I think, to finish. So I'm just going to copy this text. Right. And I'm going to add the asset. Yeah. So the due date for this one will be a week from today. So today is September 4th. So on the 11th by 10 p.m. It's going to open now, and it'll stay open until the 14th. Sunday. All right. Does that make sense? So that's your homework assignment. Should be pretty easy. My goal here is just to, ask questions, get into the flow of Python. We'll be using Python a lot, right, throughout the semester. So this is your moment, your chance to ask questions and to understand it really well. All right, so yeah, so I think we're ready. We can go ahead and think about it. So it's already in the notes. Where did I? If we go back to the resources, go to the GitHub. So the code is provided. It should be under classical. This one here, classical. You can get classical algorithms from there. And then the problem somewhere here. Yeah, it's this one. So inverted number cipher. So that's what we're going to cover. So, or a substitution cipher. So this is the problem. So the inverted number cipher concept is like this. We're going to convert lowercase letters A through C to numbers in reversed order. Does that make sense? So essentially you have a letter. We're going to convert it into a 2-digit number. And we're going to use the ASCII table for it. So I provided an ASCII table, I think in one of the folders. So you can, one of the modules, I should say, so you can use that. So for instance, here's an example, A26, B25, C24, all the way to C1, okay? And so that is the essential idea. We don't want to hard code this, so we don't want to have like a table that maps B to 25, etc. Instead, we want to do this through a function, right? And take advantage of the structure of the ASCII table. And then we're going to have some additional functions that we need to use. So we want to convert each character, possibly to lowercase. For each character, we convert it into a number using the ASCII table. We can use this function ORD and the CHR function, which are two Python functions that allow us to use the ASCII table essentially, right? And map numbers to characters, characters to numbers. That's essentially the idea. All right. So, and then these are some of the tricks and ideas that you have to implement. So for instance, the plan would be, we're going to take, this is, the Department of CS at LSU. We're going to take that string and convert it into numbers. And then once we have the numbers, we're going to convert that back to text. Got it? Any questions about the problem? Nope. All right, so let's go ahead and start coding this up in Python. So we're going to go to the virtual machine and just start creating our first Python script. By the end of the semester, you will have 20 Python scripts and you will be able to use them, right? So you'll be able to encrypt things. Remember that sometimes we have to encrypt for key exchange, sometimes we have to do encryptions for integrity, sometimes we have to encrypt for confidentiality. So all these scripts are going to help you, or OpenSSL. So these are essentially the tools. Okay. All right, and then the decryption idea is there. There's the pseudocode if you want to read through it, but I'll go through that in the lab. So I think I need to start my virtual machine. And I'm going to start laying out the functions that we're going to use. And then we're just going to fill in all the different details. All right, so we're going to log in. Okay, so let's open up the terminal. ULS-L. I have a folder for this. So I want to go to my folder. Um, One thing that I could ask you to do for this example, for instance, if I extended it, is to use files, right? And that might be something. Eventually, we will need that. We will need to read in data from files into our programs to do the encryption. It'll just be more practical. So I might do that today just to kind of give you the basic idea of how that works. Okay. So a lot of these things that we do in one class we'll be using in other classes later. Okay. So I had created a folder, 2025. This is going to be like the second lab. I'm just going to call it the Substitution Cipher. Okay. We want to go in there. Here we are. Any questions? We're ready, right? So I'm going to create a script for this. I can reference my classical example, for instance. Right, so usually we'll have a couple of functions. We've defined those in like the theory. We'll have an encoding function and so encoder, decoder, or encrypt, decrypt. And so I use Nano. I'm going to use Nano to create the script. Yeah, so I'm going to just call it substitution cipher.py. Okay, so that's my script right there. If you've never used Nano, you use this when you want to save, Control X, Y, Enter. Okay, so a lot more friendlier than Vim or VI or something like that. All right, so we're going to have, a main section where we call the functions. So this is just a comment. I'm going to call it main. And then we're going to need something to encrypt, something to decrypt. So I'm going to call this plain text for now. Plain text. And we're going to encrypt something. This ITS 350 in the CIT program or cybersecurity or something like that. So just something that you can encrypt, okay? That's the idea. We don't know what the decrypt is right now because that's obviously going to be produced by the algorithm as a number. So later on, we'll have something like the cipher. Oops. Cipher, and it's going to be some kind of a sequence of numbers. There's a few things we need to address, but I'm just going to make a random sequence of numbers right now, and we'll go from there. Okay? So once you have a cipher, once you have a plain text, the next thing is you want to have the functions for encrypting and decrypting. I'm going to do cipher equal, and I'm going to create a function called encrypt. And the function encrypt will take the plain text message, the plain underscore text, right? So a lot of our examples will be like this. Then, of course, we may want to decrypt. So I'm going to have decrypted plain, which means, it's not we don't want to overwrite the original plain just in case. And we're going to create a function called decrypt. And the function decrypt will take in as input the variable cipher. Got it? So that's essentially, a lot of our algorithms will be like this, but instead of using, substitution, we'll use XOR or RSA or something like that. But the structure is going to be pretty similar. All right, and then, within these functions, we can have other functions, and I'm missing a sign mistake. Okay, and then once you have your message, for instance, cipher, we can print cipher just so that we can take a look at it. Okay, so I have now defined this. So the next step is, of course, to define my two functions, encrypt and decrypt. Later on, we will also use more libraries, like we'll use PyCryptoDome or some other libraries to have more functionality, more power. But this we're building from scratch, so we don't really need any libraries at this time. So I'm going to have two functions at least, encrypt and decrypt. And we'll start working through the problem, and then find the basic logic that we need. All right, so let's go ahead and lay out encrypt. And we have encrypt. So colon, and remember Python does not use curly brackets like in C. Instead, we use indentation. So you can use a tab or spaces, just don't combine them. I like spaces, and I use 4 just for readability. So 1, 2, 3, 4. And then I'll add a return. All right, and then I'm going to do the decrypt function. Decrypt, again, colon. Notice I haven't provided the arguments yet, but we'll fill those in a second. Again, indentation, 1, 2, 3, 4, and then turn, and just return nothing at this time. Okay, so this is the idea. So then, I think the problem said, so in encrypt, we want to take A, right, and it should be 26. So we'll add this as a comment. That's kind of like a rule. So A should be 26. B should be 25, and so on. Okay, so we want to do that. As this is going down, eventually, we're going to have letters that correspond to just a number like 7. But to make it less complicated, we'll add a 0 in front. So if we're using a 7, then it'll be 0, 7. That way we have 2 digits for every substitution, and that'll simplify the problem. Obviously, all these decisions I'm making are adding patterns to the cipher, which of course is going to make it less secure. All right, but it's just to get this going. All right, so we probably should start with encrypt. So at this point, we have this, and I'm going to turn off decrypt since I don't need it. I do want to print the cipher at this time. I don't need decrypt. We haven't defined it. So yeah, this should run. So I'm going to do Control X, Y, Enter. Now we can run it in Python. I think you guys have to type Python 3 here. Python 3. Mine works with just Python, but Python 3. All right, so I provided passed an argument, but I haven't defined it in the function, so I'm going to go ahead and do that. So if you look here, I'm providing to encrypt plain text message, but I haven't passed anything up here. So I'm going to do that. Plain, something like that. All right. So now the steps that we need to follow are we need to read in the plain text message, iterate through the letters, right? And then convert every letter to a corresponding number, accumulate that as the cipher, and then that's going to be our encrypted message. And that's, our substitution. So let's go ahead and do that. Let's think that through. So let's just, make sure we're, the code always works. So the first thing probably, okay, we're going to need to let's print the characters in plain. How about that? So we have the letters. This is ITS 350 and the CIT program. So we want to print those out since we're going to be doing the substitution for every single letter. So I'm going to do, so I need first of all the length of plain. So I'm going to do plain length, right? And I'm going to say len of plain. Okay, so that's it. Then I'm going to need some kind of a loop. So 1, 2, 3, 4. For I in range, colon, plain length. Plain length, so 1, 2, 1, 2. Okay. And now we want to print out all the letters in here. So I'll do 1, 2, 3, 4. Now 1, 2, 3, 4. And we're going to print. Okay. So, the string is just like a buffer array in Python. So you can just do plain square brackets. But here we're going to provide the index position, I. Okay. So that way we can iterate through all the letters. So hopefully this should work. So I'm going to do Control X, Y, enter, clear. And there we go. So you can see I was able to print these. Notice there's a few issues, like there's space. So how is that handled? Well, we are going to be using the ASCII table, and in the ASCII table, there is a character called space, right? So that corresponds to a number. By the way, I keep saying the ASCII table, which I'm sure you guys know what that means. But if you don't remember what one looks like, I provided one, at least a couple of times this semester, at least, for sure. This is one time. So it should be under, I think in the first week I added it. Yeah, so here's the ASCII table. So this provides letters to decimals to hexadecimal, right? You can see that there. So we are trying to convert A to decimal. Do you guys see that? So the letter A, but in the ASCII table, the decimal is 97. But the rules say that of the problem, we want to use 26. You see that? And then we want B to be 25. So we actually want the numbers to go down here, but in the ASCII table, they're going up 97, 98, 100, and so on. All right? But that's kind of what we're doing. So there's a couple of ways of solving this. But yeah, that's essentially the idea. All right, so let's go back then. All right, so we can go back to the script. So we know we can print out the results. We don't necessarily want to print out the letters. We may want to do something else with it instead. All right, so now let's actually convert every letter into the equivalent ASCII. So that should be the function ORD in Python is a built-in function. So we're going to do plain I. And let's call this the ASCII value. ASCII val. And actually, let's print the letter and the value just to confirm that it is, in fact, the value from the ASCII table. So I'm going to go ahead and do print. I'm going to do print. And then I'm going to do print of ASCII val. Like that. Okay. So now let's go ahead and do this. Control X, Y, enter. I'm going to run it now. Okay, so you can see we've got letters and numbers. So if we look up, let's say, yeah, we print the letter first and then the number. So T is 116. T, it's 116, right? So T is 116. There you go. So it gives us the equivalent ASCII value, but we need to still do some processing for this to work as we want it. So we're going to go back to the script. Okay, So now we've got some numbers. So that, yeah, so the next point is we need to convert that number into 26, 25, and so on, right? So we need to like reverse it. So I'm going to create a function for that to separate that out. So I'm going to this is going to be my code. I'm going to call a function cipher, and the input to it is going to be ASCII val. This is the thing that I need to, if it's the letter A, right, I want to convert it into 26. We have to think about that. So it might help actually to know the value of A, right? Because that's kind of my reference. So I'm going to go back again to the ASCII table. I'm going to look up A. So lowercase a is 97. So remember that value, 97. So let's go back to the script. Okay. I'm going to define this function here. So I'm going to call it function cipher. Function cipher. This will take, the ASCII value. Okay. 1, 2, 3, 4. I'm going to call this cipher code. Cipher code. So cipher code, if it's A, needs to become 26. It's going to come in as 97, right? So let's think it through. If it's A, we want it to be 26. Oh, actually. So we want it to be 26, but it's going to come in as 97. Okay, so we need to find some kind of a formula, a relationship that gives us this, right? Do you guys see what I'm saying? So we want to invert it with some function. So just try a few things. So 97, we know that's a value. Minus, I'm just trying things out here, right? ASCII value. Okay. Oh, yeah, so I'm sure that's fine. Okay, now cipher code, of course, we want it to be 26, but we need a variable here. So cipher code. It's 97 minus ASCII value. Okay. To simplify things, I'm also going to change plain text to just be ABCD. Plain text. So it's going to be now A, B, C, D, E, let's say. All right. And we want, so this, we know these numbers, right? It should be 26, 25, 24, 23, 22. So we have to be able to print that out just by modifying that function. All I'm doing currently is in here. taking 97 minus the actual ASCII value. Let me remove all these print statements as I don't need so many of them. I'm going to remove this one. I don't need, well, let's leave that one. And then I need code here. So let's print code. So I'm going to do print code. Okay. So now let's take a look at the function. ASCII value. Oh, and then this one needs to return cipher code. Turn. Everyone with me? Right. So this, it's tricky maybe, but there's no security through obscurity, right? It's gotta be there's gotta be, you have to follow proper cryptographic primitives. All right, so it doesn't like, oh, I have a typo. All right, so there we are. So 97 became 0. 98, we have A, B, C, D, E. -1, -2, -3, -4. So at least we know that our current approach gives us a number that can be reduced from another number, right? So we have 0 or -1 or -2 or -3 or -4. So now we can use this value. Let's try. I'm going to print the letters actually. That might be useful. Right. And so you can see A is currently 0, should be 26. B needs to be 25. It's -1. Do you guys see this? So what can we do? Go to the code. And do this we want to keep. Start with 26 plus, right? So 26. So let's see what we get now. So A is 26. Oh, okay. A is 26. Oh, so that worked actually. So A is 26, B 25, C 24, D 23. Do you guys see that? So that gives us exactly what we need without having to create a table. We just use some kind of function, right, to do the substitution for us. That's a nice function to have, but it's really bad in terms of a function is essentially a pattern, right? So we've intentionally added this pattern, seems very fancy and really hard to figure out, and actually it makes the algorithm pretty insecure. That's kind of the point. But anyway, we've done this part. Now let's just continue. So I think that kind of worked actually. So then we can start encrypting. The other problem we have is once we have some letters, so let's increment the size of this sequence. So I had A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Right? So if we try this, the problem is when we get to Z, it's going to be 1, X is 3. But in the beginning, some of our letters have 2 digits, right? So we know A is 26. So to keep it simple here, I'm just going to put a 0 in front, but that adds even more of a pattern because now I know it's, these little blocks of 2 digits. If somebody looks at that, immediately they can start to see a pattern, right? The second you do some cryptanalytics, and we'll talk about this in a second. But you can, in fact, maybe see what's going on. So I'll play with that in a little bit. All right, but let's finish the algorithm first. So I'm going to do clear here. I need to add that part, right? So this gives me my code. So essentially, I don't think I need to modify this function anymore. So I can just go back to the original encrypt. 1, 2, 3, 4. 1, 2, 3, 4. Make sure the indentation is correct. So I get a code. Now I need to check if that code is going to be an integer at this time, but I'm going to want to convert that into some kind of a string. So I need to check if that code has 2 digits or 1 digit. So we can do something very simple like if code less than what? 10, right? Less than 10. So we know it only has 1 digit, else it has the 2 digits. So I'm going to create something called S code, which is a new variable where I'm going to hold these codes. Now, S code just means string code. So I'm going to convert it into a string. So S code, I'm going to initialize it to blank. So now, if code less than 0, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So S code will be equal to, and I'm just going to accumulate these. So I'm going to use S code plus 0 as a string. So this 0 is a string, not a number, plus my code, which I'm going to typecast as a string. So str. Okay. So that way I take a number 7, I put a 0 in front of it, but it is now 07, a string. And then I'm just going to append that at the end of a string to create the whole cipher. That's essentially what I'm doing. So this should happen if it's less than 10. If it's, greater than, then it has 2 digits. So I don't need to append that 0. 1, 2, 4. 2, 4. Okay. So this is going to be just S code equal S code plus here, in Python, remember, plus can be adding 2 numbers or concatenating 2 strings, right? So that's something you just can't do, concatenate an integer and a string because they're 2 different data types. All right, so you can do here string code, and there you go. So now we've done this, and we're almost done actually. What else do we need? I think we're almost done. So once that's done, we've essentially created our. Yeah, please go ahead.
I was just gonna handle capital one. Because those don't capital one, you don't have.
That's a good question. So because we're using the ASCII table, is it possible that maybe it just handles it automatically? Because uppercase letters are in the ASCII table, right? But if you go back, see here, there. So maybe the beauty of this is that it can handle spaces, numbers, things like that. Maybe. All right. So yeah, so that's a good question. We'll see what happens. Let's not worry about it, but yeah, good question. So let's go ahead then. So I think we've created our cipher, our first cipher. So let's go ahead and take a look at it. So I'm going to run that. I think that's going to print. I think I did that. Yeah, there it is. So you can see this is your cipher. first of all, your ciphers are going to be binary, like secure ciphers are going to be actually binary. We'll see that later. Well, you've already seen it when you open OpenSSL. Ciphers, they're already binary. At best, we can convert them into hexadecimal, but this one is already just a string of integers. Okay? So that in itself is, it's vulnerable, right? It's a weakness. We're going to do some cryptanalytics in a little bit, and I'll show you guys, how we can do that. But you guys are already familiar with this because you've watched the show Wheel of Fortune, right? So you know Wheel of Fortune. What do you know about Wheel of Fortune? When you start a puzzle, what's the first two, three letters that everyone picks? You already know the most common vowel, right? What are those? In English, E and an S, right? They even have like special rules for those letters sometimes. So this is the heart of cryptanalytics, right? Because a lot of the time you're trying to decipher some secret message that's written. So you're going to look for a number that's occurring with a certain distribution or some pattern in the cipher that's occurring with a certain distribution, and that might have the same statistics as the letter E or the letter N, and boom, you have something, right? So we'll visualize that in a little bit, but that's kind of the idea, right? Yeah, so language has these statistics. This was proven. Claude Shannon actually, once again, did this when he was, creating his field of information theory. He just took a book, started looking at letters, computed the statistics of it. And so language, English or any other language, they have very specific statistics, right? And based on those statistics, even if you've done something like substitution, they're still there. And so totally breakable, like in seconds, right? So that's why this is pretty bad. But we'll take a look at that. All right, so I've managed to create my cipher here. This is what you would send to your friend, right? What they need to do now is they need to decrypt it. Notice also we didn't use a key really. We're just using a substitution cipher. Like in the past, they had like a little book, right? And they would just but that's not great in this approach because it maintains, as I said, the statistics of the language. All right, so let's go ahead and think about that. So we're going to go back to the code. And we've done these functions. Now we need to reverse the process, right? We need to reverse the process of encryption and decryption. We're going to do that in a second. All right, so I'm going to now enable the decrypted uh, decrypt function, right? And I'm also going to print the decrypted cipher just so I can take a look at it. Print decrypted plain. So I'm going to print decrypted plain, right? So we need to define decrypt. So decrypt just takes the sequence of numbers, and we're going to start defining it here. So I'm going to put in this function. We're going to define that one. So this is going to be cipher. Okay, just like that. And once again, we need to, this is, remember, it's going to be a sequence of numbers. There's 2 digits per character. Okay, so the first thing we probably want is just a way of iterating through it. Okay, there's a couple of ways that you can do this. Python makes it pretty easy, and I'll show you how to do that, but we do need the length. So just like before, so this is going to be length of cipher, and I'm going to do len cipher, just like that. Okay, len cipher. All right, then now I'm going to iterate through it. So a for loop. So I'm going to do 1, 2, 3, 4. Okay. And I'm going to say for I in range. And I'm going to set a starting point, which is going to be 0, to length cipher. But instead of grabbing every character as we did before, right, for the letters, here we need to grab every 2, right? Every 2 characters, which are every 2 digits. So this is equivalent to in any other programming language when you guys did something called the step size, right? You had a step size and you move the index by so many steps. In Python, you can just do that. And now we've defined the step size to be 2. So it's going to grab 0, then 2, then 4, then 6, then 8, and so on. So it can slice out, we can slice out the 2 characters that we want. So we can do, we need the code. Oh, and there should be a colon here. 1, 2, 3, 4. 1, 2, 3, 4. There we are. So now the code, right? And let me add a space for readability. So I have a variable, the code, and I'm going to grab the 2 characters. So the 2 characters could be 0, 3, or it could be 17 or 26, right? So, but I'm grabbing them as strings. So I'm going to grab them first as cipher I, which in the first iteration it's 0. I need to grab the second one, so that's going to be I plus 1. I'm going to concatenate them because they're still strings. Cipher, this one should be I plus 1. Do you guys see that? So this should give me all the digits. So just to corroborate, well, I'll print cipher in the code. So all right, so decrypt the cipher, and we're just going to print. So I'm going to do print the code like that, right? So I'm going to print that. Okay. So let's try this out. So Control X, Y. Yeah, I think, yeah, it works, right? Okay, so yeah, I'm doing the letters. So you can see 26, 25, 24, 23. You can see that. And then for the ones 03, 02, 01, I have them here at the end. So I'm able to break up that sequence of numbers into the individual 2-digit pairs that make up, you know, the for the substitution to happen. But of course, they're not corresponding to the correct ASCII numbers right now because we did that whole shifting, right? So we need to reverse that now. So we're going to have a process of reversing that. But for now, these are strings. We want to convert them into integers. So we're going to go ahead. That should be pretty easy to do. You know, if we have 03, well, if we just do int, 03 just becomes 3. And if we have 26 as a string and do an int, that 26 becomes an int. Okay, so that should be easy. And we actually can see that. So if I do clear, you can see that these numbers no longer have the 0, but they are the correct number. Okay, so now what we need to do is we need to take these numbers and reverse it back to the correct ASCII code, right? So we need to do that. So essentially, we need to repeat this function, but kind of in reverse. Okay. And that's the key thing. I like this exercise because in all cryptography, right? In every algorithm that we do, we always have an encrypt and a decrypt. So whatever we do in the forward motion, we have to do in reverse. So any complications that you decide to add to your XORing algorithm to encrypt, you have to include in your decrypting algorithm in reverse. And we'll see that this is not so bad. It gets a little bit tricky with once we start looking at the block ciphers. So for instance, the DES, one of the algorithms, has something called the Feistel network. And so we'll see this in a few weeks. We have to go in forwards, and then we have to understand how to go back, in reverse so that we can do both the encryption and the decryption. All right, so we have to repeat this here. So now I have my integers. I need to reverse them. Okay, so that means here I need to, so I have the code. I'm going to print that. And I'm going to create a function that gives me that reversed. So in this case, yeah, this is going to be the ASCII value, the correct ASCII value. So I'm going to get that one. I'm going to create a function. I'm going to call it function plain. Keep things simple. And I'm going to pass the code to it. Right? So we pass the code to it. It should return our ASCII value. Once we have the right ASCII value, we can use our ASCII functions such as ORD and CHR to obtain the corresponding value. All right, so let's define this one, function plain. So we had function cipher. Now we're going to add function plain. Okay, so let's define it. Define function plain. This will take, call it code, colon, 1, 2, 3, 4. Return 1, 2, 3, 4. Okay, so here is where we need to do kind of the same thing as before, right? So here we want 97, given that we have code, but code is something like 26, right? So it's coming in how we wanted it to look, but we need to get it back to the opposite of this one. So it makes sense to do just the same thing kind of in reverse, right? So let's see how we can make that happen. So in the previous example, we had 97 minus ASCII value. So now let's do 26 minus ASCII plus 97. Do you guys see that? So we're just going to repeat that kind of in reverse and go from there. So 97 plus 26 minus code, right? And this should give us, let's call it ASCII. Okay, so that, oops, there's a space. And then that's going to give us the ASCII to return. Okay, so let's see what happens here. And from there, we'll adjust it if it doesn't work. So function plain returns the value now. And now we just want to print it to see how close we are. Since we're still using ABC through Z, we should be able to spot any problems. I'm going to do print ASCII value. All right. So hopefully that makes sense. So let's go ahead, try it out. Okay, so kind of hard to tell because I think I have some of the old prints still enabled. So let me disable some of those now. So we're just going to focus on the, yeah, so I'm going to take these out because encrypt seems to be working. So going to add just a line so I can tell, make it more. All right, so let's try it out now. Okay, a little bit better. So the first letter, the first number is 26, then 25. That's A and B. So that should be 97 and 98 if we look at the ASCII table. So A should be 97, B should be 98. So let's see how close we are. Oh, there we are. So A is 26, 97. B is 25, 98. So we actually got it correct. Do you guys see that? Well, that's it. So we reversed it essentially, and we're able to get back the original value. So hopefully then we can decrypt. All right. But if there's some kind of error, we can figure it out. Okay. So now let's go back to the script. Okay, so that returns the value here. And now we need to accumulate these ASCII characters, right? In some way so that we can print them. But also these are numbers currently. So we need to now take ASCII value and convert it to the actual letter. Okay, so I'm going to call this letter, although it could be a number, just, some variable to hold it. And I'm going to say CHR ASCII value. All right, and now we just need to accumulate this in some string. So I'm going to do decrypted plain, initialize it to that, and then now take that letter and just concatenate it at the end. So that's going to be decrypted plain. It's going to be equal to decrypted plain plus letter. All right, and so now hopefully the final thing is to return decrypted plain. Everyone with me? Any questions? Right, so this is your first script. And a lot of them will be like this, obviously, but the functions will need more details, XORing, things like that. One difficulty possibly is that we're going to be processing things as byte arrays instead of strings or integers as we are now. Because obviously for real crypto, it'll be a byte sequence. All right. And I don't mean that you convert into zeros and ones as a string, right? We're going to be operating at the byte array level. So the data structure, underlying data structure is a byte array. All right, so now let's run it. And it produced nothing. Did I not print or something? All right, let's see. Let's take a look. So I decrypt into decrypted plain. So it does everything in a loop, returns. So decrypted, yeah. So did I not do something? I feel like some step is missing. Letter. Let's print letter, I guess. I'm going to print letter, right? Then I should be assigning it to. Oh, okay, I see what happened here. I have a typo here. You can see I added two Y's to that. Sorry about that. All right, so this should be working now, but let's try it. Okay, so I'm printing letters, obviously, and you can see I have A, B, C, D all the way to Y, Z. Got it? So with this, I'm able to kind of figure out the algorithm. Now let's go ahead and switch the input to the actual sentence, the secret that we want to send. Okay, so I'm going to come here. I'm going to go to the main section, and I'm just going to comment out this ABC, right? And instead, I'm going to try to encrypt and decrypt. This is ITS 350 and the CIT program. Now, if someone had a question, what about uppercase letters? Well, let's see what happens, right? Let's see what happens with the uppercase letters. Since we're using this generic approach with the ASCII table, maybe it solves it for us. We do have spaces in there as well. So let's see what happens. All right, so let's go ahead. And as you can see, it even handled spaces in uppercase seamlessly. Got it? All right. So a couple more things we have. So that's essentially your lab for this week. Just make sure you do this, try different things, right? So I have two more things I want to do. One, if time permits, obviously your data will need to come from files, right? And this is going to be throughout, whole semester. When we encrypt things, it's going to be byte arrays, so we're going to need to save it as byte arrays, just like OpenSSL did. Send that out. That's not that difficult, actually. Python has a nice function, read and write, and all you have to say is, okay, I want it as a string, or I want it as bytes, or something like that. Okay, so that should be easy to do. But we want to, let's say that you're sending this secret to your friend. It's probably not just going to be that. It's going to be way more information. So you want to save it to a file, and then you send the file, right? Or they send you a file and you read in the file. And then the other thing we want to look at is what I was talking about with the cryptanalytics, the statistics, right? So the pattern persists for some letters, right? So, but how do we create this, right? How do we visualize it? So let's think about that one a little bit. So I'm going to go to here, to the nano example. I have, I think I wrote a sentence. Yeah. This is ITS 350 in the CIT program. So you can already see there's a few letters that are being repeated, like the letter T is being repeated a lot here, right? But we all know, because, if you've watched Wheel of Fortune, right? You know that the E is the most common vowel, and then NS, I think, right, are the consonants that are most common. We've watched that. So let's try that out, right? So let's say just, I'm just so that we can kind of spot it. Um, but we need to know what number. But actually, it's a good example, right? I don't know. Don't tell me. I don't know the number for E, right? Let's just with E. Let's just to simplify, right? So what I'm gonna do is just, what's one word with like seed, right? The seed lab. So seed. So there's two E's there. And then I'm gonna do said. I'm gonna do said. And I'm gonna do said. Said, right? Do you see what I'm doing? So I'm actually adding the S also. So let me then change that. I'll do it once for seed. Then this one we can change to uh, met, right? Met. And then give me a word for this one. Just keep one E. Doesn't matter. Like, so let's do 11. 11 has threes, right? But it's a common vowel, right? And then I have this said, and I'm going to do step, right? And then and leave that one as said. Okay? So all I'm doing is trying to like simulate that in language you would have these common letters that would appear a lot. Like, you know, if it's a big message, let's say it's like a whole plan or something, um, there would be these statistics about language that are reflected, and that's what you would look for in whatever substitution they have done, and therefore it's insecure. So I'm going to do Control X, Y. So don't look up what E is, right, in this example. Since we're not using the ASCII, you actually can't look it up on the ASCII. You'd have to do the math, right, to figure out or print the code. So we don't actually, most of us probably don't know what it is. But let's see if we spot something. Oh, and actually, I don't want to, I'm going to hint. So let me do this. So let me go over here. I'm going to remove all the prints because by accident, one of the prints might give it away, right? So we don't want that either. So if I miss a print, let me know because one of these prints could ruin the whole thing. Print, right? And all we want to show is we print the cipher and then we print the decrypted, right? And we already know what where I'm not printing the plain either. So yeah, so it should be fine, right? So everyone understands what I'm doing. Okay, so let's now, hopefully this works. Okay, great. Oh, let's remove that one too. Don't look at that. All right, here we are. Now, do you see a pattern? Like it might be not so easy, right? But what do you think? Not so easy, right? It's a bit tricky. But a computer program would solve this in seconds, right? So it would find like the correct one. So what do you think is the likely? So there's one letter in here, the E, that we've intentionally made very frequent, right? I see a lot of twos. Is it 22? Yeah, you think it might be, right? So that's one thing, like anybody that, and this is called cryptanalytics, right? So cryptanalytics of all classical methods, you break it. You write a program, done, broken. AES, DES, they're supposed to be very secure, right? So it has to be a brute force type of an attack, those kinds of things. But cryptanalytics should be hard. If you're able to do cryptanalytics on modern algorithms, there's something really wrong with it. Okay? But so yeah, so you think your theory is 22? I do see it seems like there's a lot of twos. Anyone else want to? A lot of nines? So you think it's either, okay, there's a few nines, you're right. So somebody says 22. What do you say? Because it's got to be two digits, right? 91, I guess. 91. All right. So yeah, so that's so now we can print the last one to figure it out. Okay. So now obviously we know just by looking at the last one, 23 actually, right? It seems like it's 23.
You could just make the plain text just be E and C.
Hmm?
You could just make the plain text be just E. There.
Oh yeah, that's true. That's true. But actually, so it's a good exercise, right? It's super breakable and we're still having a hard time. So you can see why many people back in the day before the 40s would still think this is secure. And put in context, there were no computers then, right? So it was still kind of hard. Turing, broke the Enigma machine with a computer, and they can, it becomes very easy. Claude Shannon actually looked at the whole of language, right, and found that there's statistics. And of course, you guys know this because of Wheel of Fortune, where it's always the E and the N and the S and something like that. But yeah, so T seems to be 07. Well, yeah, so that's kind of there's a pattern there of yeah. All right. Any questions on this one? Does it make sense? Yeah, we could at some point in the semester. There was a problem in the PDF if you looked that it was kind of like this. And they wrote some code. We may at some point in the semester do something where we look at statistics, but I don't know. I mean, at the end of the day, this is the only very insecure algorithm that we're going to look at, a classical substitution cipher, just to illustrate that they're not super great. And then moving on, we're actually doing modern type of algorithms post the 1940s, which are based on Claude Shannon's ideas of what is, like the one-time pad and beyond. Okay. All right. So hopefully that made sense. The last part for today, to wrap up the assignment, is reading and writing, right? So I'm just going to show you guys how to read in and write out. This is going to be super easy because it's just integers and strings. Later, we're going to have to read in byte arrays and write out byte arrays, okay? Because that's really how you want to send your file in a very secure fashion. So let's go ahead and add this part. So I'm going to start with reading the file. So here I hard-coded my all right, so here I hard-coded my message. So this seed is yeah. So now just to read it, I'm going to in Python you do f equal open, and then you say what file you're reading. So for instance, it's going to be a local file. I'm going to call it plain.txt. Okay, so that's my plain message. So obviously my message is going to be there, right? And you can say here usually comma. So you will say things like read, write, append, RB, read bytes, WB, write bytes. Okay, so those are the tricks so that we can, process our files. Okay, so in this case, but the default one is read, and that's what we're doing. So, but if you're reading a byte array, then you have to say RB, which in a couple of weeks or so, we'll get to that. So now, plain text is going to be f dot read. Should be like that, right? And then I'm just to make sure, I'm going to say plain text print. I want to print this one just to make sure I read it correctly. And I'm going to use an input to hold the program. So this is like holding it for me to. Yeah. Oh, yeah. Thank you. Yeah, so it should say plain text. Thank you. All right, and the input also, you could have read from the input, like you just type it there, but it's better just to have a file. So we need to have plain text in there, but that should work. So I'm going to do Control X, Y, Enter, ls-l. So now I need to create the plain text.txt. And I'm just going to say, it's September 4th, 2025, just to make sure it reads something different. Okay, so let's go ahead and run it. Oh, okay. So plain text. Just like that. Perfect. So we're able to read, and I halted the program. If you can see, you have to press enter. Oops, or to so. All right, so let's go back to code. So now we would the cipher. So this print decrypted cipher. So we'll do something very similar. And by the way, whenever you use F3, make sure it closes. This I'm going to say now it's a different variable. Equal. I'm going to create a file. This is what. Well, I want a cipher really. Cipher data dot. And here I'm going to write. So the write as a string still, or but I'm writing. Okay. So then I'm going to f underscore out dot write, and then okay. So that's essentially those 3 lines that we use for doing it. So 90% of the approach we will take, and maybe sometimes we'll use a couple of things. All right, let's see if it works. So run it. input is still there. Okay, it gave me an error. Oh, that's right. I did get it. Right. Good point. So if you notice here, I'm typing F out to the output file, but I did not give it anything to write. So I need to write a cipher like that. Okay, so now I should be running the file. Clear here. All right, no error. Now we do ls-l. We can see we do have cipher data in it, because it's got 122. So let's take a look. Cipher, and you can see my sequence of numbers. Does that make sense, guys? Any questions? Right, that's it. That's your first cipher, right? An insecure one, a substitution cipher. But in Python, a lot of these things we're going to reuse later. Just don't send your banking information using. All right. All right, and then we'll stop here.